Designing something like the hull of a ship can be an expensive process. So how do you rigorously test out a design before you even build it? A unique research program at the University of Iowa makes that possible, using sophisticated software, model ships, and an enormous indoor pool. Professor Fred Stern leads the University of Iowa's Ship Hydrodynamics program, the home of this high-tech facility.
These are called wave basins. You can see the wave makers at the far end here. They're plunger type. They go up and down. They generate either regular or irregular waves in the basin. The next part for us then is the carriage. This is a custom designed carriage. It follows the model. There's targets on the model that the cameras and the tracking system use. Ours is unique insofar as it's designed specifically to carry measurement systems to measure the local flows around the free-running models.
Believe it or not, this nearly $5 million facility was designed and built primarily for the purpose of validating or testing computer code. That code, CFD Ship Iowa, is a simulation software developed at the University of Iowa for the Office of Naval Research. In the past, Stern and his research team validated the code by running their models in a 300-foot-long towing tank. But as computer power grew and the code became able to do more advanced simulations, so it required a more sophisticated tool for validating.
Our codes developed very rapidly over the last really 5 to 10 years, to the point that we were able to predict the exact trajectory of the model, including rudders and rotating propellers, and no longer restricted to captive simulations. Therefore, to validate it, we needed to see, well, how accurate would the trajectories be? By trajectories, I mean models, for example, you start out straight ahead, you give the rudder a 35-degree angle, and it's going to go in a circle. We want to know what's the radius of that circle. Another type is a zigzag test, where you put the rudder 10-10, 20-20, and then you predict what's known as the overshoot. There's half a dozen or so of these traditional tests, both in calm water and waves, that ships have to be able to demonstrate the capability of performing to a satisfactory standard in order to be built. And so our focus is not actually design. Our focus is development of the tools.
While the wave basin will enable new advances in hydrodynamics, Professor Stern says it indicates the direction much of science is already heading.
You know, the future of engineering is simulation-based design. And in fact, we can simulate things we can't measure. So you begin to see a major shift in the scientific method, where we went from Aristotle, who based everything on logic. He didn't bother to, he thought men and women had a different number of teeth in their mouth. It's one of my favorite stories, but of course they don't. And he could have figured that out easily by just looking in his wife's mouth, but it cut in their teeth. But no, some logic, and no validation. Galileo said, okay, validation, experiments, physical observations. But there's limits there too. Now we come back to, if you think of simulation technology as really logic. So now we're coming back to logic though coupled with the experiments. This is the engine of simulation-based design. And in that sense, each of these steps are just little, steps along the way. We'll always need the smaller facilities, the medium-sized and the larger facilities. This facility is half the size it should be for actual industrial use, but for basic science, it's just perfect.
To learn more about ship hydrodynamics and the science of all things fluid, visit iihr.uiowa.edu.